Here's our video on identifying quadratics. So, a quadratic equation will create curves, which we call parabolas. So, we have something that could look like this. It could look, that's facing downward, or it could be face upward, and so forth. It also form like to the left or to the right. That's what a quadratic is. So, the word quadratic comes from Latin, comes from quadrare. And in a quadratic equation, the highest variable, the highest exponent, is a 2, actually. So the highest exponent is a 2. And this is the standard way it looks, where the exponents decrease. Right? So the highest exponent is a 2. So again, the word quadrare is in Latin. It means to make square. So and you see the square, x squared, right? We know if we see that squared, it's quadratic. So again, it makes parabolas. The parabolas, how you spell parabola right there. The parabolas are the curves. Now in the next video, we'll talk about how to solve quadratics, and we'll get something like this on a graph. So here we have a parabola that's facing upward. And if it faces upward, it's positive, but we'll talk about that later. It has its peak, which we call the vertex, and it moves upward. And it has its roots, which I'll talk about. So this parabola here, this is a quadratic. It opens upward. We have its roots right here. We'll talk about that. Now, one thing we should look at is if the x is squared, sometimes the y could be squared. So if we look at something like this, y equals x squared plus 6x plus 8. We'll look at this example. Here we see that the exponents are going down. They're decreasing in value. That's in standard form. The x is squared. Now sometimes the y will be squared. But if the x is squared, you know it's going to either go up or it's going to go down. And if the x is positive, here you see the x is positive, so the parabola will face upward. In the parabola, we have, in standard form, we have y equals ax squared plus bx, bring that up here, plus c. So the a represents the number next to, the coefficient next to x squared. In this case it's 1, and the b represents the 6, and the c will represent the 8. So this is how it looks. So if I gave you a question like this, like that, if I gave you y equals 8x squared plus 3x minus 2, that over there so we can see it. Well, here we have the 8. We have the 8 as the a, the 3 as the b, and the negative 2 as the c. So again, if the x is squared, the parabola is vertical. That means it's going to open up or down. First thing to look for. Here we can see the x is squared. So we know it's going to either go up or down. We'll just put anything in here. So the a is 1, the b is 12, and the c is negative 5. Now if the y is squared, it's going to be horizontal. So it's going to either open to the left or right. So if we have a y squared, so if it was y squared, you would see the y squared. And we'll talk about that in another video. Because if it opens to the left or to the right, it's not a function. Right? This is not a function. It doesn't pass the vertical line test, which we talked about when we talked about linear equations. So, if the x is squared, it's vertical, as we see here. And if the y is squared, it's horizontal. Now, if the a is positive, the the parabola opens up or to the right. So let's look at that example again here. Here, A is 1 and it's positive, so it's going to open upward. And since A is positive, then it's a positive parabola. If A is negative, it's going to open down. So let's do an example here again. This is a positive parabola, and it opens upward because A, right here by the A is 1. Remember, that's A, and that's B, and that's C. The A is 1, and the A is positive, so it's going to open upward, and it's a positive equation. Let's look at this example. What is this? Well, A is positive, so it's going to open upward, and it's positive. Quadratics should always be set to 0. So when we had y equals x squared plus 6x plus 8, we want it to be set to 0. So in actuality, it's x squared plus 6x plus 8 equals 0. We want it to get to equal 0. Now, if you saw something like this, x squared plus 6x equals negative 8, we need to put it in standard form. Bring that negative 8 over by adding it, so it'll become x squared plus 6x plus 8, and then it would equal 0. So again, we want quadratics to be set. So again, in standard form, this is what we want to see. We want to see ax squared plus bx plus c. That's the standard form. A cannot be 0. A cannot be 0. If a is 0, then you cancel out the x squared. You don't have a square. In this example here, we have x as 1. We can set it to 0 like we did before. X squared plus 6x plus 8 equals 0. That's what we're trying to do. So tell me, with this equation right here, is it negative? Does it open up, down, left, or right? Which one? In this equation right here, does it open up to the left? Does it open up to the right? Is it negative or positive? Well, look at A. A is negative. It's a negative 1. So we know this is a negative parabola. And since it's negative, it opens down. It'll look like that, something like that. What about this one? See if you can do that. Pause the tape and see if you can tell me if this is negative, positive. Does it open up? Does it open down? Does it open to the left? Or does it open to the right? Well, remember now, we need to put it in standard form. And remember, in standard form, it should look like this. So, we want that negative 8 out of there. First thing, we put y equals negative x plus 10x squared plus 8. Now we want it in standard form, where the highest exponent, which should be a 2, if it's not a 2, it's not quadratic. We want that first, so it'll be y equals 10x squared minus x plus 8. And we could set the whole thing to 0 also. 10x squared minus x plus 8 equals 0. Now, a is 10. It's positive. It's a positive parabola. And since it's positive, it's going to open upward. Right? It's going to open like that. So again, remember, place in standard form. Set it to 0. Which would be 10x squared minus x plus 8 equals 0. We know it's upward because it's positive, and a is positive. Now, in the next video, we'll talk about how we could solve quadratics. We can solve them many ways. In the next video, we'll factor quadratics and put them on a graph. Great job.